Thank you again for joining us for Lunch with DASI. My name is Jim Byrne, and this is the SolidWorks mating call. We've got a lot of tools to cover today, so let's get started. I'll give you a brief agenda as far as what we're going to be covering for the webinar. I'll start with, I suppose you could call it a toolbox of tips for using mates inside of SolidWorks, for the creation of the mates and working with the mates once they've been placed in the assembly. And I'll also talk about best practices. I'm not going to spend a lot of time on the PowerPoint. Almost everything will be on the SolidWorks screen, but I do have one slide where I'll walk through some best practices to keep in mind. And also some advanced mating options that are available. I'm not going to spend a lot of time on, for example, creating coincident and parallel and distance mates in this webinar. We don't have time for that, so I'm going to try to cover as many advanced topics as possible. And, I also have a customer example that I'll bring up on the screen, and I'll do my best to make sure that I cover all of these items within the 1 hour period. Let's jump into SolidWorks. The first item that I'd like to walk through, many of you are already aware of this, is using the mate reference tool and the smart mate. So I'm going to start fairly basic, and then we'll move into some more advanced topics. And hopefully you're going to find some tips and tricks along the way. Now, I want to start with mate referencing. I'll bring up a new assembly document. Let's see, I'm going to drag and drop in a base, first of all, to start with. So I'm going to put together a rack system. I'll start with a base or a post. Now, when I drag and drop these parts in, I'm going to be talking about mate referencing. There is a mate reference on this part, and I'll show you what it looks like in just a moment. Now, notice when I drop these components in the assembly, it is automatically generating some mates for us to position the component. In fact, I'm going to go ahead and open up this one right away and show you the post. This is a sub-assembly. And inside that sub-assembly, I've got a couple of mate references. And I'm going to show you how to make these. But let me start by editing one of the mate references I have in the tree. I have this floor reference, first of all, that is using planes or faces as a primary or tertiary reference entity. And the thing that this is more of an advanced mate reference, because you'll notice that the name of that mate reference is going to match the name of the base that I have inside of that main assembly. So if any of your mate references are named the same, it's going to try to use those together when you drag and drop that component into your assembly document. So more on that in just a minute. Let me go ahead and drag and drop in a couple more components. The main thing here is when you drag and drop these items in, it's going to look for other mate references. For example, I'm going to drop this one into place, and it's automatically going to establish a concentric relationship there. And this one has several configurations for single clamps or double clamps. I'm going to go ahead and choose one of these configurations. My purpose here is not to talk much about configurations, mostly about the mates. So we'll talk about configurations on another day when it comes to assemblies like this. I'm going to go ahead and smart mate this component in place. Many of you have used this tool already. When you drag and drop a component around, it just simply moves it with your left mouse button. If you hold down your Alt key on your keyboard before dragging it, it activates the smart mate. At that point, you can let go of the Alt key. And we can drag that face to another face, and it will ask us what type of mate relationship we want to apply. In this case, I'll leave it as concentric, and I'll do the same thing over here. Hold down my Alt key and drag that face to this other face. Again, go ahead and accept the concentric. Then those concentric mates have been applied, just like any other mate that you use inside of SolidWorks. Let's do this a couple more times. I've got a series of components that we can drag and drop in, and actually it's a series of configurations within a component. Again, this is kind of another story that we can bring up later, but I'm going to go ahead and drag and drop this one into place. Notice it will use the mate reference that's in that component, and we can choose the configuration that we need. And I need a couple of those, so I'll drop one right here too. Well, when I take a look at the hardware, I'll open up this subassembly. Once again, there are multiple mate references in this one for each one of these clamps. I have the axis mate reference for dragging and dropping this subassembly to one of the posts. And then I've got a separate mate reference for each one of these clamps for dragging and dropping in the organizer. And we'll be again making our own mate reference in just a moment. I'm going to change the configuration of this one to a large drawer instead of a small one. How about another hardware connection? We'll drag and drop in another one of these. Again, that mate reference is in place. And I'll add just a regular mate relationship between these two faces. I quite frequently use the pop-up toolbar to access mate instead of going to the assembly toolbar to create these. I'm going to drag and drop in a screw, one of these Allen bolts. Now before I do that, I'm going to go ahead and open this up in its own window. Right now, if I drag and drop in that bolt, I can just place it anywhere I want in the assembly and then mate it in place. But I'm going to create a mate reference through the reference geometry flyout. See, there's mate reference. This is done at a part or subassembly level. And you can choose faces or edges as primary, secondary, and tertiary reference entities. Now, in this case, I'm actually going to pick on just this edge as a mate reference for a bolt. And that's all I'm going to choose. You don't have to have a secondary and tertiary entity. And it gets placed here in the tree. Now, I'm not concerned with the name of this mate reference because this is just a basic one. I'll show you how it works. Okay. Now, when I drag that bolt in, notice I can place it anywhere I want inside the assembly, but when I hover over another edge, it's going to automatically add a couple of mate relationships for me. Simply hover over that edge, and you don't need to be right on it. You can just be somewhere close. And you'll notice that when I take a look at the mates for that component, see, it created a concentric and a coincident relationship on the faces of those components, not the edge that I selected as a mate reference. So keep that in mind. I'm not mating edges here, even though I picked the edge as a mate reference. It knows to pick the faces that are associated with that edge. Let me mention the smart mate again. I'm going to drag a copy of that bolt over here. If you don't use the mate reference, then you can use smart mate, where again you hold down your Alt key and you can drag and drop a face to maybe another cylindrical face, or a flat face to another flat face. Or you could also hold down Alt and drag this edge to this edge. And again, it creates the mates between the faces and not the edges, which is important. Let's move on to another assembly document. Maybe before I continue, I'd like to know a little bit about everyone who's in on this webinar, what your experience level is. Go ahead and take a look at the screen and answer the question that I have here. I put it up just a moment ago, so if I spelled anything wrong, then forgive me. This will give me an idea of what types of tips and tricks I should give during the webinar. I'll share the results so everyone can see the type of experience that we have in the webinar. All right, I want to take a look at how you work with mates inside of your assembly documents, and then again later on we'll get to creating some of these advanced mates. I want to start with how many mates exactly I have inside of this assembly document. There's quite a few that are in the main assembly, and I have some sub-assemblies in here too. So if I take a look at my assembly expert under the Evaluate tab that will show me how many mates I have in my main assembly, which is 63. But the total number of mates that I have in here is actually over 250 when you consider the mates that are in those sub-assemblies. If you have a lot of mates that are in your main assembly tree, and we're going to work on that in just a minute, it can be difficult to find the mate that you're looking for. And I'm going to show you about 4 ways of looking for mates. And many of you know some of these already. For example, an easy one is choosing the component, and then you've got an option to view just the mates on that one part. Right? Now this is going to show you, not only show you the mates for that component, you'll also see the parts that are grounded and the ones that are just mated to this piece. And this can really come in handy, because if I suppress the parts that ground this component, then it keeps the mates it keeps the mates in play for the ones that are mated to this piece. You know, for example, now if I close out of this, then we can just move that part out of the way, and everything else is still mated to that component. Okay. So again, choose that part, click on View Mates, and I'll go ahead and unsuppress those to bring them back. Another one that some folks use, if you look at the component in your tree, any of these parts, you'll notice that there's a folder to show all the mates that are connected to that component. Now, speaking of that, when you go to or right-click on the assembly at the top and go to Tree Display, you may also like to use View Mates and Dependencies as an option. That way, when I expand these components, it shows the mates right away, and then the features end up in a folder instead of the mates being in a folder. Okay, so this might be a nice way of working on or working with the mates that you have in those components. Right-click on the assembly tree display, and I'll go back to View Features to bring it back to where it was before. Let's see, I'll bring up another method. Now this one isn't probably used quite as often, but when you choose a component and then pick on the Property Manager tab, it will list the mates for that component. If you select 2 components using your Control key and click the Property Manager tab, then it will show the parts, it will show the mates for both those components, but in bold it will show you just the mates between those 2. Now the only reason I don't use this a whole lot is because that tab keeps going away, but if you drag that Property Manager tab to another location on your screen and click on that push pin to keep it visible, then when you choose the components, it will show, let's expand that a little bit, it'll show those mates for just that one piece. Or again, if you hold down Control, then you can pick on 2 parts and it will just stay up the whole time. So this may be a nice tool for you to use. Drag the Property Manager off to the side. So I'm going to go ahead and put this back. Just drag it over to one of these squares. It can reside in several locations on your screen. Another thing that I might use sometimes is this, if you want to select the components that are mated to this component, you can pick that face. There's a select button up here. Oh, mine is missing. I also have it, if you press your S key on your keyboard, it pulls up your shortcut toolbar. I want to use the select tool to pick on components that are mated to this component. And I'll Control select that one and right click to isolate. Just those. Okay, so again, you can view parts that are mated to this one and then simply exit isolate when we're done. Okay, choose a part, use the select tool to pick on parts that are mated to it. There is another one, just one other tool, and just this works for several areas, but there's the filter bar up here at the top. If I want to, here, let's create a mate so I can use this one real quick. I do need to add a quick limit mate to this assembly, because right now my jaw for the spreader is it's passing right through each other. So rather than using collision detection, we'll choose these 2 faces and add a limit mate. This mate has actually been around for a few years. At one point it was maybe the one of the top 5 enhancement requests for SolidWorks to make limit mates. So this is an advanced mate in your property manager for adding mates. I'm going to add a maximum and a minimum distance for a range of motion between those two faces. So this way, when I move this component, you notice that it will stop at 0 and at 60 millimeters. Okay, so that way we don't have to use collision detection there. We can also move these components over here as well. Okay, and I'll use the limit mate again a little bit later. This was mainly to show you the filter bar. Oh, and by the way, here's another select option. Use the select tool to pick on all hidden components and show those. There's also the show wall at the top of your assembly tree, but I thought I'd mention that one. If I want to find all mates that have the word distance in them, then we can type in distance right here in the filter bar. Now I'm getting everything showing up in my tree, so a lot of times I'll right click in here, or no, excuse me, even quicker. We'll click on Shift C, and it will collapse everything for you. Then you can just expand the mates and show those. So everything that has the word distance in it, or coincident or concentric, use the filter bar up here at the top to find just those types of mates. Let's take a look at some tools that you have available to you. Now, I have a couple of components. I'm going to go ahead and just isolate these two. I've got this bushing and a screw, two of these components, and I'd like to place them in other areas of this assembly. A lot of times you may find yourself holding down Control, and you can make copies of these components and then mate them in place. But instead I'm going to use a command called copy with mates. And you can find that under your, if you click on your S key and expand the insert components, you'll find copy with mates right there. Or you could also put this button anywhere you want. And see, if I pick on the bushing, you'll notice that there's 3 mates connected to that bushing. If I pick on the bushing and the screw, then I'm down to just 1 mate that I have to copy, because it's automatically going to copy the mates between those 2 components. And this is real simple. You're just going to pick on that reference for that 1 mate and other locations, and then right-click to accept it. See, it keeps the tool up, so you can choose your reference, right-click to accept, choose a reference, right-click to accept, and then you're done. So I've copied. I just found out my arm hit my mute button. So I'll apologize for that. Try to avoid the button from now on. The other thing that I want to mention is the amount of mates that we have inside of this assembly document. We have quite a few. Now there's more than 63 because we added those other components. The amount of mates that you have in your main assembly is going to affect performance when adding new components or adding new mates. So it's a good idea to utilize subassemblies as much as possible, okay? Because these subassemblies will contain the mates inside of them, so they don't reside under the main assembly. It's going to help with performance, and of course you can reuse those subassemblies in other areas or other assemblies too. Now, you don't have to form your subassemblies before you place them in your main design. You can do that while you're inside of the main assembly. For example, I'm going to grab these 2 components, right-click, and I have to click on this little double arrow for now, and form a new subassembly here. Well, it creates a virtual assembly inside of your main assembly document. And if I expand that, you'll notice that it moves the mates between those components into the subassembly level. It moves them from the top level. And if you have additional parts that you want to place in there, simply grab those, and you can, again, drag and drop them right into that subassembly. And it moves those mates with it too. I'll grab the rest of these components that make up that sub and move those in. So by doing this, if I go to my assembly expert, I'm down to 39 mates in my main assembly document at the top level. Okay. Now the things you want to watch out for in this case, there are going to be times where you'll have over-defining mates for the location of that subassembly, or if you created an exploded view for your main assembly, you may end up having to delete those steps and redo them. Is whether the parts are in a subassembly or not, that makes a difference to the explode view. Now, if you want to move these components around, you can move them anywhere you want because the software rebuilds or resolves the locations of these components simultaneously. So if I move this, I can move the subassembly up here to where the other subs are, but I don't want to place that part into this subassembly. So I'm going to hold down my Alt key on my keyboard so that it just reorders it. It doesn't put it inside that one. Oh, again, and this is a virtual subassembly, so when you right-click on it, you can rename it and then save it as a file. Save the subassembly as a file, otherwise it will remain as a virtual subassembly inside of this one. Oh, and speaking of subassemblies, another thing I'll mention is these subassemblies are by default solved as rigid, meaning that if you have an actuator that you're placing inside of your assembly, it will not move. It won't retract and extract. If you want that subassembly to be able to move, then you'll select the subassembly and pick on component properties. You'll have the ability to solve that as a rigid, a flexible object. And this works great. Just make sure you know that flexible subassemblies are very heavy inside of your main assembly documents. So only use this tool when you absolutely need to have that motion in your design. Let's also take a look at replacing components. I'm going to open up one of these subassemblies. And I want to address real quick replacing components. See, I might want to replace this handle, which is the base of my assembly. Pretty much everything is mated to that. And now the part that I'm replacing is actually a part that was not saved as a copy. It's a whole new component. So the mates are not going to be maintained. And you may come across that sometimes. Well, I want to address that. Let's go ahead and replace this with another piece. I'm going to replace it with this handrail. And now when I accept this, I'm going to pull up the other property manager to reattach the mates because they're going to all be invalid since it's a new component. And see, I've got lots of invalid mates. Well, don't let this scare you. You can very quickly and easily reestablish those by using this tool. Now, if you accept this, you can still get back into the replace mate entities command. Sometimes I keep the other parts up while I'm replacing these, so I can move that out of the way and then choose a new reference. But other times too, I'll make this easier on myself and only show the selected entities, so the other parts will be hidden. All right. Okay, so as we work through these, you notice that again it highlights the item on the old component so that we can replace it with something new. And you can always right-click to accept these. If you pick a face, then right-click to move to the next reference. Okay, pick it, right-click, pick the new reference, right-click to accept it. And another thing that I do at times is if I'm having a hard time picking the face, click on your X key on your keyboard just once, and it will turn on your filter face so that you won't accidentally pick on an edge when selecting these references. Okay, finally I've got this face right here. Oh, did I miss one? This one down here. So you'll notice that I no longer have any invalid mates inside the property manager. I can continue to accept this command. I've got another poll question that I want to bring up real quick before I move on to this other topic, and this has to do with the size of your assembly documents. So answer this one for me. Second, I'd like to get an idea of how large your assembly documents are. I've actually seen an assembly that was over 1 million components. They were, granted, they were all very basic parts, but it was a huge assembly. Okay. I'll go ahead and share this one too. So nothing that's real large. We have a lot of customers that have easily more than 10,000 components in the Michigan area here, but it doesn't look like that's the case. Let me just bring up real quickly, if you're having any performance issues with large assemblies, I won't dwell on this for too long, but I'm going to open up another assembly document. Actually, I'm going to bring up a couple items that pertain to performance. One of them is called SpeedPack. SpeedPack allows me to get a simplified configuration of this subassembly that I can put into my main assembly document. By right-clicking on this active configuration, I'm going to add a SpeedPack. A lot of times I'll just find myself selecting faces that I think I might want to either measure or add a mate relationship to. So I'm just going to randomly pick on some faces. I'm not going to get real technical here. And when you accept this command, you'll notice that you get this lightweight configuration. As I hover over it, I get that ghost appeal to faces that I didn't select. So now if this subassembly is placed inside of my main assembly using that SpeedPack configuration that's now nested underneath this other one, I'm bringing this up in the mate webinar because it's a simplified configuration, and we can select those faces for mates. So I might want to mate, for example, these two faces together. Pick a couple concentric faces. There's a lot more to talk about when it comes to SpeedPack, but I just wanted to make sure that this is an option that you have for mating components in very large assemblies. And of course, we can switch this SpeedPack configuration back over to a regular configuration if we want. Okay. Another thing that I want to discuss as far as performance is concerned, I'm not going to show this as an example, but when you open up an assembly, there's two options. Let me start by picking an assembly. There's two options that you'll need to know. One is lightweight, this checkbox right here. If you open up an assembly lightweight, then it only loads the geometry or the solid body information for those components and not the feature history. Now, I bring this up because a lot of you may be avoiding lightweight because of mates, but keep in mind that you can mate lightweight components because it does have that solid body information available. By the way, if you are not using lightweight opens up your assemblies at least 2 times faster, sometimes up to 6 or 7 times faster, depending on the size of the assembly. Quick View is another option that came up after lightweight. If you check this box, it enables you to select the components that you want to work on before it loads everything. And it literally, anything that you don't select does not load. The only issue with that is when you, let's say I suppress components in my assembly, it also suppresses the mates. But when you use Quick View, it doesn't load those components. It's kind of like leaving them suppressed, but the mates are still maintained. So this is also another thing to keep in mind when it comes to mates, that if you use Quick View and only load a few of the components, all the mates are still maintained. Let's talk about mate errors a little bit. If you've been using SolidWorks in general, you'll come across mate errors. It's just something that especially if you're making changes to your assembly, everyone has to deal with them. So I'm just going to walk through this real quick. I could probably spend an hour just on fixing mates or fixing errors that you have inside of your assemblies. But I'll just walk through one quick example here. I've got some moving components on this, and I've got some mates in here. We could take a look at those mates, but I'm just going to go ahead and over-define this assembly. Because we have the show preview checkbox down here, it's going to let us know right away that the mate is not going to work. Oh, and speaking of which, we have show preview as an option. Another one that a lot of folks don't tend to see is used for positioning only. You can actually create a mate, or you can use the mate tool to position the parts, but not actually make the mate. So keep that one in mind too. I'm going to go ahead and force a coincident relationship, and if I accept this, it will ask me, do you want to force the one that you just made, or do you want to just leave it as an overdefined mate but not force it? I'm going to go ahead and force it. Click yes. And by doing that, it of course causes a bunch of problems. It's going to yell at me. If you see a red X over a mate, it means that it can't show that mate. And the other ones with the yield signs are just they're just shown in conflict with each other. If you pick on the overdefine item in the status bar down here at the bottom, then you'll see the little view mate dialog come up. And here's the mates that have issues. The red one is can't be shown unless I right click on it and select force to force that mate. And then there's going to be another one that's broken. And if you choose these mates, then it also pulls up a little flyout where you can right click to make changes to that mate, or there's also a flip mate alignment, a force option, edit mate option, suppress option. See here I can force that mate too. I might find myself doing this sometimes, right clicking and forcing mates until I find the one that I can either suppress or change. See, here's this one between those two faces. I may want to either suppress it. You don't necessarily want to delete these mates because you might decide later that you want to keep it. It's always better to pick on the suppress button instead. Or if you think you want to change the mate, you can also pick on the edit button and change it to a parallel mate. And notice before I even accepted that mate, it shows that it resolved the issues that we have with all the mates in this assembly. You know, there's another thing that I might want to mention in this design. If I'm going to view the mates of this component, see I've got a concentric and a distance mate in here. Well, if I want to flip this component around, you saw this just a moment ago, we have the option right here to flip that alignment. It not only flips the alignment of that mate, but it also flips the alignment of this one too. And sometimes that can cause problems. Now in this case it worked just fine, but if you're flipping the alignment of one of these mates and you don't want it to flip the other one, SolidWorks added an option for this. It's under assemblies. See, there's a checkbox right here to prompt before changing mate alignments on edit. So you might want to check that box. Actually, I believe that this is a default for SolidWorks now, and I actually added it to my list of things not to do, not to ask me for. It's one of these in here. So keep that in mind. There is an option to prompt the user before it flips the alignment of other components. All right, well, let's take a look at some mates. I think I'm going to show you examples of at least the path mate, width mate, rack and pinion, and gear mate, and see if we have any time for others. We'll go with a path mate first. This is a conveyor system that I'm using, and there's actually 2 path mates for every rib that you see here. And there's no belt in this case. It's just a single component that's extruded to a depth. And now if I take a look at the mates for one of these ribs to view just those mates, See, I've got these two path mates, and I'll start with the driven one. See, under advanced mates, I've got a path mate generated between the vertex of the rib, and I created a group of edges. And actually, I should probably mention choosing that group. Let me cancel or clear the selections here a second. If you want to select a group of entities, right-click in space, choose your selection manager, and then when you choose an edge, there's a propagate button right here to propagate around tangent edges, or you can just continue to select additional edges manually and click on this green checkbox. And then that will create a closed group. Now in this case I'm modifying this one, which I don't really want to do, but that's how you get a group of entities over in that box. Now there's that path mate. Oh, let me jump back in there a second. This one, for the path constraint, I've got distance along that path. Okay. Now in the other path mate, see, I had one for this point. Now I have another path mate for this point, for the other one. I left that one as free. So this one is just free to ride along that path. Now, if you have SolidWorks Premium, then you can apply a motor to that path, and I'll show you that real quick too. If you're using the Motion tab down here at the bottom of your screen, and you have SolidWorks Premium, see, that gives you the ability to pick on motion analysis in this flyout. Then when you apply a motor, everyone has rotary motors and linear motors, but with the motion package, you've got pathmate motors where you can select that pathmate and apply a displacement or a speed. In this case, I have a velocity that's applied to each one of these ribs or those pathmates, so that when I play it, each one of those ribs is going to move along that path. Okay. That's actually something that is new in the software. Hasn't always been there. All right. Let's take a look at another example. I'll open up this table. Now with the table, I want to mention the width mate and the rack and pinion mate. See, right now these components are pretty free to just move on by themselves. I'd like to start with a width mate in this case, and many of you have used the width mate already. I like to pre-select my faces for the width mate. So if I choose these faces ahead of time on both sides, I have 4 faces picked total, and then I pick on mate. Then it automatically knows I'm trying to create a width mate, which is an advanced mate. The thing with the width mate is you just want to make sure that you pick 2 faces for one component, and then either 1 or 2 faces, it doesn't have to be 2, for the tab selection. And then it acts like it's just a quick way of adding of centering components without having to use planes. So if I accept this one, you'll notice that I can now move these 2 pieces symmetrically. Now they're going to pass right through each other. Okay, so maybe what I want to do is add a limit mate as well. So I'll pick on these 2 faces. We added a limit mate earlier. Under advanced mates, there's our limit, which can be a distance or an angle. Now keep in mind that whenever you add a limit mate or a distance mate or an angular mate, What's another good one? When you add these types of mates, even distance mates, just a typical standard distance mate, take longer to solve than coincident and parallel and perpendicular. So keep that in mind. You might not see a significant difference, but they do take longer to solve. Let's see, we'll make this a maximum of 25 between those two faces and a minimum of 0 and accept that. So now we can move these and we'll stop when they run into each other. So it's kind of a nice way of showing that range of motion without having to use collision detection. Another one that I'll mention here is the using the rack and pinion mate. And a lot of times I find myself just moving these somewhat close to to where I want them to be. We can move those around a little bit. Actually, there's something that happens on this one that I'll mention too. But I'm going to go ahead and add a mate between. It's best if you pick a pitch diameter. If you have a sketch in there, it makes it a lot easier. And we'll pick on one of these edges of another component. And we'll make this a mechanical mate. See, I've got several mechanical mates available. Let's make that rack and pinion mate. And we can define this using a pitch diameter, or you could use travel, the range of travel as an option, and enter in your values. Okay. Now it went in fine, but sometimes I've had it where, oh, see, there it goes. It shifts my components a little bit, so that the ratio is actually right, but it moved it when I accepted it. So I guess in some cases I find myself taking that mate and suppressing it for a second, and then I'll move it into position. There we go. And unsuppress it to bring it back. It should be fine. Okay, or maybe edit the mate and accept it again. So you run across those sometimes. Now the other one up here, I didn't actually add a rack and pinion mate. This one needs to be fixed too. But I have there's a gear mate between these two components. So I don't have to add a rack and pinion to both sides. And that might actually save on performance by doing so. Okay, so there's a couple of examples of those. And I brought up the motion analysis tool just a moment ago, and I have a couple of minutes still left. So let me bring up another assembly to discuss a tab that's in the motion property, or I'm sorry, the mate property manager that you might be interested in or wondering why it's there. Now, if you're not interested in motion analysis, then this might not mean much to you. But when you're adding mates to your assembly document, in this case, it's just going to be a bunch of concentric and coincident type relationships or distance relationships here. Well, when you do that, when you add concentric relationships to every single set, that's fine as far as SolidWorks is concerned. But if you're trying to get reaction forces off from those mates, well, the problem is you're creating redundancies between those mates. You're eliminating just 1 or 2 degrees of freedom using several mate relationships. In fact, if I pull up my motion tab, we'll notice that it tells you the number of redundancies right here. I've got 8 redundancies. Okay, which is fine for just moving the parts, but not for getting actual kinematic results. SolidWorks added this other tab. If I edit one of those mates, a concentric mate, this one right here, some of you might wonder, what is that analysis tab? Well, when you choose it, there's several options in here for motion, like for example, adding a bushing. If I check the box for bushing, it removes those redundancies because basically what happens is it takes the center of that mate and it mates it like a point. So now when I accept this, it makes it like there's 2 points that are mated to each other instead of the 2 faces. In fact, it puts a little bushing symbol next to the mate. When I play this one again, it should actually say 6. I didn't remove all the redundancies in this case, but the main thing is just understanding exactly why that tab is there, the analysis tab, so that you can use bushings to reduce the number of redundancies that you have between your mate relationships when you're running a kinematic analysis of your assembly. Otherwise, what happens is you have to delete all those mates and apply them in a different way. This makes it a lot easier. Let me jump back into my PowerPoint a second. I want to just walk through some of the notes for working with your assemblies. Some things you might want to just keep in mind. Number one, all the mates in your tree are solved simultaneously, so it doesn't matter the order of those mates. Okay, the only reason you reorder them, I guess, is just to make them easier to find for yourself. And when you're creating mates, focus on mating faces in reference geometry. Avoid especially mating two cylindrical edges. Do not mate those together if at all possible. Just avoid them because it will allow you to do it, and it's okay at times. Distance, angle, limit, and limit mates do take longer to solve. In fact, speaking of distance mates, a lot of times you might want to use an assembly layout, like create planes or sketches inside of your assembly and mate to those for the locations of your components rather than using distance mates. First of all, it solves faster, and secondly, it makes it easier to change your design because you just need to edit the sketch that the parts were mated to. And another one is, let's see, okay, flexible sub-assemblies. Again, they're great to have, but they are very heavy, so keep that in mind. Avoid mating to anything in the mate folder, like under the mate folder, did I say that? Like component patterns, assembly features, like cuts or assembly or planes that are referring to parts in your assembly, and in-context features, if you have features that are related to features and parts that are related to other parts. Avoid mating to those items. And I suppose if I bring up SolidWorks real quick, let me show you what I mean by that. Here's a mirrored feature down here at the bottom. See if I suppress this. All these components on one side were mirrored onto the other side, which is great. SolidWorks does an incredible job of mirroring components, but you want to really avoid mating to these pieces on this side. Now, why is that? Because anything under this mate folder has to be rebuilt before the mate that's attached to one of those components. If you create a component pattern, it shows up below the mate folder. If you create an assembly cut, it shows up below the mate folder. So SolidWorks is going to rebuild these mates until it runs into one that's related to something down here. Okay, so it's going to take longer for the assembly to rebuild. Keep that in mind. So don't mate to anything down here if at all possible. Sometimes I'm sure you can't avoid it. They call those time-dependent features. Now, be careful when using split lines on your components too, because if you mate the component in the assembly and then you split the face of that component, or especially the face that's mated, then that face will become invalid. And unfortunately, that's just something that you'll have to deal with when creating split lines after the part is mated. Just keep that in mind. And try to avoid chains as much as possible. I've got a couple diagrams down here. The first one is a good, solid method for mating your components. Avoid chains in this case. Sometimes you can't avoid that, of course. Maybe a good example is if you have a shaft or a bushing or a screw. You know, if, for example, you've got this red piece as your bolt or your shaft, you want to make sure that you mate the yellow piece to the blue one. Don't mate the yellow piece to the bolt or the shaft or bushing. Okay. The last thing I might want to do is pull up a good example of an assembly that came from a customer. This is courtesy of Ben Harrington over at Peloton. I don't have a lot of time to discuss it. We can at least pull it up because it's a nice example of using a combination of gear mate and the path mate. This might look familiar. You'll see it in a vent for an automobile. Now I'm going to take a look at just the moving components for right now. So you'll notice that in this assembly there's a path. There's a couple of path mates that are used. There's also a gear mate, of course, between these components. So as you move these pieces, the reference geometry in here is going to follow those paths. Okay, so I've got a path on this slot right here. That pin is going to follow that. And then in turn, it's going to move some of the other components in the design. So this is a good example. I like to see examples. If you have any that you'd like to send my way, I'll be sure to maybe even use them in a future webinar. If you're going to join in on one of our webinars, then and you have something that is a good example, please send it my way. And if you given your permission, I'll use it inside of the 1 hour session. That's all I have on mates in SolidWorks. Thank you for joining us on behalf of SolidWorks. Check out our website for future webcasts regarding the SolidWorks family of products. And I'll stick around for questions if you have any. For the rest of you, enjoy the rest of your day.